Welcome back, my extraordinary mathletes. All right, guys, so you're watching this video because I told you to watch all your videos before you came to class. Good job, you! Hopefully you guys have your popcorn ready to go, maybe a little piece of paper over to the side just in case you want to jot down some notes or do a little practice. You will recall this crazy cool long division problem that we did on Monday's Teams meeting, where we just kind of took a look of, hey, what do I know about long division? And at any point, if you need to whoa, slow the roll here, MSO, you can always pause. Then we looked at this problem, right? And I've got a lot of extra lines and things like that going on here, so we'll just erase the ones that are less important. We talked about how you could use kind of our long division algorithm to tackle this situation with dividing a polynomial, all right? And we also talked about the fact that learning how to divide a polynomial will help us to break down polynomials into linear factors so that we can find the roots or zeros of the function. So that is the purpose of this skill, right? I also alluded to the fact that in addition to long division of polynomials, we do have a different kind of division that is called synthetic division, okay? So what I'd like to do real quick is I'd like to do one more long division example, and then I want to show you how you can use what's called synthetic division if you are dividing, and this is the only tricky thing about synthetic, which is why we need both. Synthetic division only works if you are dividing by an x minus h factor, right? And of course that could be, you could be dividing by x plus 2, you could be dividing by x minus 6, right? Essentially what you're saying here is then that this linear factor would have a root or a 0 at -2, and this linear factor would have a root or 0 at 6, okay? So we're kind of incorporating all this information into this division and solving process. Okay, let's move this crash course forward a little bit. Okay, so this is a really ginormous, yes, definitely a word, polynomial. And we're going to see if it's actually divisible by m plus 1. So we're going to say m plus 1. And I'm just going to talk you through my thinking on this. I have an m to the 5th, and I have an m to the 4th. I want to have a degree of an m to a certain degree represented in each space, kind of as a space holder. So for example, I was missing an m cubed term. I would just put in 0 m cubed. So this one's kind of nice because I have all of my descending exponents represented in this work. And this is a very long problem to do for a video, but that's okay. Here we go. So to see if m plus 1 divides into this polynomial function, and let's just make sure I've got all the numbers right before we get started and get crazy, okay? You're going to ask yourself, what do I multiply m by to make it an m to the 5th? So that is going to be an m to the 4th, and as you multiply, we get m to the 5th. M to the 4th times 1 is plus 1m to the 4th, and remember you subtract, just like long division. Okay, so let's cruise through this. Hopefully you guys aren't here to shout at me if I make a mistake, so hopefully this will go okay. -5m because it's -4 minus 1. Then we bring down our -10m cubed. It's looking like a 6, but it is a 10. And you ask yourself again, what do I multiply m by to make it a -5m to the 4th? And you think for a minute and you're like, oh, golly, what should that be? Oh yeah, it's going to be a -5m cubed. And then we multiply. So here we go. We're going to multiply just this term, just this negative 5m cubed term. And you're going to multiply it by each term in the m plus 1 polynomial. So we have negative 5m to the 4th and negative 5m cubed. And again, we're subtracting. Don't forget we're subtracting. These two will cancel. Because we're taking negative 10 minus a negative 5, that's going to be a negative 5m cubed. You ask yourself again, what do I multiply m by to get negative 5m cubed? And it's a negative 5m squared. So let's try that. Negative 5m cubed and then negative 5m squared. Again, we're subtracting. Just keep going. Subtracting that, looks like we're going to get a, let's see, is it going to be a negative or a positive? Positive 1 minus a negative 5 should be a positive. And then I bring down my 11. Then you ask yourself, what do I multiply m by? Remember, we're coming back here. Let me get rid of our little blue arrows here and here. What do I multiply m by to give me a 6m squared? And you're like, oh, that's going to be 6m. So 6m squared plus 6m. We're subtracting, which leaves us with 5m, and then we bring down our 1. And what's left? A times 5? Looks like it, right? I'd have to multiply m times a 5 to get 5m. So that's my last little piece there, a plus 5. And so 5m, and oh no, I would love it if it was a plus 1 because that would mean that m plus 1 was actually a factor, but it's not, and that's okay. We're just learning how to divide. So 5 times 1 is going to be 5, and again you subtract, and those cancel, and you're left with a negative 4. So the answer to your division problem is actually going to be m to the 4th minus 5m cubed minus 5m squared plus 6m plus 5 with a remainder of 4, which you would say write as a fraction over your divisor. Just like that. Crazy, crazy, crazy. Okay. So just when you thought it couldn't get any crazier, this is what I'm going to do. I'm going to move this down. Oops, can I do that? No? Okay, 1 second. Okay, I'm back. All right, so I'm going to write this solution that we got. Oops, just a minute. Right here. M to the 4th minus 5m cubed minus 5m squared plus 6m plus 5 with the remainder of negative 4 over m plus 1. Now, the reason I wrote it just a little bit lower on our page is we are going to take this example, and it is a huge, long, crazy polynomial division example, and we are going to try to do it with some synthetic division, okay? And I want our answer close enough that we can compare in just a minute. Okay, so same problem, same exact problem. And what we do in synthetic division is we're going to grab the coefficients of each of these terms. So that's going to be a 1 with the m squared, an 11, and a 1. And you keep the signs. And we're going to treat this like an x minus h. And so the h value here would actually be a negative 1, right? So what you're looking for here is we're going to actually divide by what we hope, right, is the h value of this linear factor in any given case. Okay, so here we go. Kind of set up an upside down, sort of like a, I don't know, a tray, I guess we could call it. And we'll put the negative 1 right there that we're dividing by, and then I'm going to load up this tray with my numbers that are my coefficients. And again, you want to have each descending term represented so you don't lose track. In this case, they are all represented, so I don't have to put in any zeros, but you do have to watch out for that if you are missing like an m cubed term or an m squared term or any other term in the polynomial. So here we go. It's 1, -4, -10, 1, 11, and 1. So 1, 2, 3, 4, 6. Okay, so those are all my terms. Okay, so here we go. It's a crazy little algorithm, and it works every time. Okay, so we're going to start by just dropping our 1 all the way down. Okay. Then what we're going to do is we're going to multiply the -1 times 1 and put it in this spot. Okay, and then you are going to add going down. So that makes it a -5, right? Then you're going to multiply again, -1 times -5, put it in this spot. And then you're going to add going down, -5. Is that okay? So far so good? Then you're going to multiply again, -1 times -5. It's going to be another 5. And then you add going down. It's going to be a 6. Multiply, add, multiply, add. Okay. The number in this spot is your remainder. Oh my gosh, that should look familiar. The number in this spot is your constant. The number in this spot is your x term. This will be your x squared term. This will be your x cubed term. This will be your x to the 4th term, and so on. So the answer to this division problem is x to the 4th minus 5x cubed, right, because you put these together, minus 5x squared, because you put those together, plus 6x plus 5 with a remainder of a -4 over your divisor, which was x plus 1. Now, I don't know if I can get them both. Maybe if I squeeze this down a little bit. Oh, this is going to work. There you go, guys. Look at that. So what you see here is you see a long division process of a polynomial giving us a result. And now look at this. I used x's instead of m's. Sorry about that. This is exactly the same result as you saw right there, right? Oh my gosh. Mind blown. All right, thanks for joining me. Go on to the next video. See you in class.